So now we're going to start a new unit called Kinematics. And to introduce this unit, I want to start off with just a quick video of an overview of the 5 equations of kinematics. So with any question in this unit, in our kinematics, whether it's linear kinematics, one-dimensional or two-dimensional, we're going to have these 5 equations that we'll be using. So you can see them on the left of the table here. The equation, we have 5 of them. And I've organized them to also show the variables that are used in the equation and those that are not included. So to know our variables, it'll be important to look at this text here in green. V1 is going to be the initial velocity of our object. V2 will be the final velocity. Sometimes these are also called VI or VF. And then the delta D, this triangle here is called a delta, and it stands for the change. So anytime you see this delta something, it'll be the change in something. So here we have delta D, that'll be the change in position, also known as the change in displacement. Now, depending on your teacher or the textbook you're looking at, this will sometimes just be called D. They'll just take out the delta. It means the same thing, or sometimes it'll be called delta X or just X. So you just have to recognize what version you're looking at, and they're all the same thing. You'll just replace, if you see, if your textbook uses just a X or delta X, just replace that in these formulas, and it'll be the same thing. Next is A, that's our acceleration. That'll be usually in units of meters per second squared. And the T, obviously this should be the most straightforward. T stands for the amount of time that has passed. So any problem that we're given, what you'll see is that you will be given 3 variables, and you will have one that's an unknown that you're trying to find. The tricky part with kinematics is choosing, okay, which of my 5 equations am I going to use for this problem? So for example, and we'll do examples of this later, this video, I'm just running through these equations, and then in the next one we'll start doing some practice problems. But with every single problem, it's going to be the exact same every time. You're given values for 3 variables, and you're going to be asked to find the value of a 4th one. And depending on which 3 you're given and the 4th that you're hoping to find, that will determine which equation you're going to use. So for example, if you are given an initial speed, here, let's write this down. Imagine you are given in a problem an initial speed equals something, and you are given an acceleration, and you are given a time, and you want to know a distance. So you have an object, you know the starting speed, and you know how fast it accelerates for how long. And the question asks, okay, well, how far does it travel? Well, you're going to look at these 3 variables and this 4th one that's unknown, and find out in which of the equations contain all 4 of those variables. So we need V1, and we need A, and we need T, and delta D. So our answer is going to be this one. See, so V2, the final velocity, is not included in this equation, but look, we don't need it for this problem. So in this case, we're going to use equation 2. And you'll see this is the same process we're going to use with just about every single question we're given in this unit. Just at the bottom here, we got one bonus equation. This should be one you might already know, and that is the displacement is equal to the velocity times time. It's not one of our 5 linear kinematics equations, although this is another one that you will sometimes have to use to solve your problems. But this is just 3 variables. It's typically your simpler equation. But that's all for this intro video, and if you stay tuned, we will be doing some examples in the next video.